Alright, I want to show you two things today. I want to show you what a polynomial is, how we name them, and then I also want to show you how to add and subtract them. So the first thing I have here is a little vocabulary. This is our first polynomial we'll see on the page. So a polynomial is an expression consisting of variables, coefficients, which only uses addition, subtraction, and multiplication. It also has those exponents in there because they are multiplication. So look at this. We have 1, 2, 3 terms here, and I know those are separate terms because they are separated by addition or subtraction. In a term, you can have multiple things that are glued together with multiplication. But again, that addition and subtraction are the thing that breaks them apart. Sometimes you can have like terms that you need to put together, like this negative 5x and this 2x, that's really negative 3x. So when you do that, you add their coefficients, and that goes into our third word right here. A coefficient is a number in front of a variable. So anytime you're going to combine like terms, make sure you just add their coefficients. Don't touch anything to do with their exponents. But that does bring up a new point here. A like term does have to have exactly the same exponents. So had this been a negative 5x squared, now I cannot add these two terms because they are not like terms anymore. So when we are, I have an example right here. Sorry, I don't want to get ahead of myself. This is a polynomial. Right now it has 1, 2, 3, 4 terms, but we do have some coefficients there I want you to pull out. So a coefficient, again, is something in front of a variable. So we have 3, 4, and 6 are all coefficients in that polynomial. Negative 10 is not a coefficient. Negative 10 does not have a variable, so we call that a constant. How many like terms? We've got the 4x here and the 6x. Again, the 3x squared is not a like term because it has to have exactly the same exponent. So how many like terms? We have 2, we have 4x and 6x. And let's go ahead and put those together. We've got the 3x squared out in front. 4 plus 6 is 10x. And minus this 10 right here. So how many terms? When you're deciding how many terms, make sure you do combine all those like terms. We have 1, 2, 3. In case you were wondering how I knew how to divide that up, remember addition, subtraction, break up terms. So the reason we're talking about all that is because polynomials is a very broad name for it, just like polygon. But inside of polygons, you have like triangles and quadrilaterals and pentagons and hexagons and octagons and decagons. They have more specific names for specific amounts of terms. So if I only have one term, I have a monomial. So remember, mono, like monocle, means one. If I have two terms, then I have a binomial. So bi, like a bicycle, has two wheels, has two terms. A trinomial, just like a triangle has three sides, a trinomial has three terms. So tri means three. And poly means many. So four or more, we call it polynomial because we get tired of naming them, okay? So that's just a general term for any more than 4. So let's go and add them. So one of the things I want to say that's very important is we always go in descending order. Meaning when we write our final answer, we start with the largest exponent. So as I'm looking now, I see a to the third is the largest exponent. And then I go down from there. So exponent of 3, exponent of 2, exponent of 1, no exponent. If you have something missing in between, it's okay to skip it. You don't have to write it. But always start with the largest one. If they're nice to you, like this one was, they put them in descending order for us, so our answer will automatically be in descending order, but if not, make sure you do that for me. So I'm looking at this parentheses, and I want to add it to this parentheses over here. So first thing you do is look for like terms. So I have 2a cubed right there, and over here I have another a cubed. If you need to, put in your ninja. So all we do is add like terms. So 2 plus 1 is 3a cubed. Do not add exponents, only their coefficients. I'm going to switch colors for our next term. I've got a 6a squared, positive 6a squared, and I have a negative 8a squared. So putting those together, 6 plus a negative 8 is negative 2a squared. Notice our negatives becoming a subtraction sign in between. And finally, last thing, we have some constants here. So we're skipping over just regular old a to the first, but we go right to our constants. So negative 3 plus 5 is positive 2 still. That is your final answer. Again, a real quick check. Descending order, our exponents go downhill. So it starts with 3, goes to 2, skips over 1 because there's none, and then goes to no exponents whatsoever. Now the reason for this is later on in math, you're going to use what we call the leading coefficient. Let me write that for you, leading coefficient. So if you put it in a different order, you're not wrong, but get used to starting it out this way because that leading coefficient tells you a lot about how the graph starts and how it moves when you start graphing those in Algebra 2. All right, let's try another example. So on this one, I have a 1, 2, 3, 4, so a polygon is the best name for that one, plus a binomial. They don't have to be the exact same length. We're just going to add like things together. So I'm looking here, my biggest exponent is 4x to the third. Do I have any other x to the thirds? And the answer is no. So I'm just going to write that down here again. Can't touch it, can't add anything to it. Then I'm going to go to my negative 6x squared. That's the next biggest exponent and the next one in line right here. So if I have negative 6x squared, looking for other x squareds, there they are, 5x squared. So negative 6 plus 5 is negative 1x squared. Now notice I didn't write my 1 because that is a ninja. You can write it or not, it's up to you. Next one is a positive 2x. It's my next biggest exponent as well. And then I have a negative 6x over here, or negative 2x over here. So positive 2x plus a negative 2x. Just writing that up there for you. Those are going to cancel because they are opposites. They are inverses of each other. And then we have one last thing left, and that is our plus 7. So it has nothing else to go with. We've used everything, so you just got to write that at the end. So check again, make sure it's in descending order. So 4x cubed squared, and then no exponents. That is added together and in the right order. So again, our leading coefficient there would be 4. Doesn't really do anything for you now, but just keep that in mind for later on in math. Now, what if you didn't get it out in this order? It's okay to have other orders. This is just a norm, how we like it. Perhaps you added this in a different order. Maybe you started with your x squareds because you had x squareds in both places. In that case, as long as all your signs are correct, then it really doesn't matter the order. So if I have a positive 4x here, as long as it says positive 4x cubed here, then you're good. If I have a positive 7, as long as it says positive 7. If I want to lead with the negative x squared, I can. Just make sure the signs in front move along with them, and you can put them in any order that you really want. But again, this is the right answer, but this is the better answer, so try to do it in descending order for me, please. Alright, now let's talk about subtracting. Subtracting and addition are really the same thing. We're not going to subtract. I want to bring your attention to this quick subtraction problem. If I said 4 minus 10, what you've learned how to do is boom boom, or maybe keep change change, depending on what teacher taught you Math 7, where you say subtract, instead you say plus a negative. So that's what we're going to do here. We're going to say plus a negative, but we're going to say a ninja 1 right before it. We're going to say plus a negative, and then we need to give out this negative 1. This is the best way to make sure all your signs are correct. So we're going to write the first one again here, 2a cubed plus 6a squared minus 3. Now I'm going to say plus in between, and I'm going to rewrite the second one with this multiplication of negative 1. So negative 1a cubed, a negative to a negative makes a positive 8a squared, and a negative to a positive makes a negative 5. So what happens is all your signs change. You might be able to skip rewriting it if you're really good at writing neatly within this parentheses right here. So all your signs change. Now we can go and add like terms together like it's a problem like above. So I have 2a cubed, so that is my largest exponent, so let's start there. So 2a cubed goes with a negative 1a cubed. So 2 plus a negative 1 is still 1a cubed. Ninja 1 if you want it right here. If you don't want it, don't put it. Next one would be a squared, right? Because after cubed is squared. And they put it in order for us again. So I've got positive 6, positive 8, so all together positive 14, a squared. And then after that, I've got a negative 3. I see it right here. And I've got a negative 5. So we're going to add those together. So negative 3 plus negative 5 is negative 8. All good. So if I asked you what your leading coefficient for this one was, you would tell me 1, that ninja in front of the a cubed. Alright, 2 more problems. Let's try them out. So again, I'm going to distribute my negative right here. So I'm going to rewrite the first one. Plus a negative 1 and distribute that out. So plus negative 2x plus 22. I don't know why I said 22 there, sorry. There's not a 2 there, there's just a negative 1 times 11, negative 11, so it's plus 11. I think I was just thinking that 2 there again. So let's go ahead and add like terms. This is a nice short one. We've got 5x plus a negative 2x, that's 3x. I've got negative 3 plus 11, that's 8. And there you go. Alright, moving on. Remember, it has to have exactly the same variables and exactly the same exponents. So let's start by rewriting this one. We've got 3a cubed minus 2ab squared. And we're going to say plus and then distribute out this negative 1 right here. So I've got plus negative 1a cubed plus 4ab squared minus 2a squared plus, b. So again, negative to positive, negative, negative to negative, positive, negative to positive, negative. So our signs all changed in that second one. So I only can add 2 things here. And the first thing is that a to the cubed. So there we go. We've got a to the cubed. If you have equal amounts of exponents, always lead with the one that has like alphabetically. So if you have just an a by itself to the third, start with that. If you also had a b to the third, put that at the end instead. That way it's alphabetical. So I've got 3a cubed and negative 1a cubed. Adding them together, I get 2a cubed. And then what does the negative 2ab squared go with? So when we're looking at this guy right here, he can only go with another ab squared. So I'm looking for ab squareds. Here's the only other one that's an ab squared. So negative 2 plus 4 makes positive 2ab squareds. So we have this leftover term right here. He doesn't have anything like him, so we're just going to go ahead and put him at the end. It would be okay to switch this order if you wanted. Nothing too strict there. It's mostly about that leading coefficient. Alright,